Section 310.15b2 of the National Electrical Code addresses the adjustment factors for ambient temperature and the number of current carrying conductors. The intent of this section is to ensure that conductors do not overheat due to excessive current or high ambient temperatures. This section requires that the ampacity of conductors be derated when there are more than 3 current carrying conductors in a raceway or cable, or when the ambient temperature exceeds a certain level. The question at hand involves a proposal to create an exception to Section 310.15b2 specifically for 3-way and 4-way switch loops. The proposed exception would state that conductors in 3-way and 4-way switch loops and cable or raceway installations should be omitted from adjustment factors, provided the load connected cannot be connected to another supplying conductor at the same time. The reasoning behind this proposal is that in many 3-way and 4-way switching methods, the load is alternated between travelers, which proponents argue eliminates the need to include both travelers in derating calculations. However, the NEC committee ultimately rejected this proposal. The primary reason for the rejection is that Section 310.15b2 is intended to require all live conductors that are carrying current to be included in the ampacity derating calculations, regardless of how the load is connected. Even though the load may not be able to be connected to another supplying conductor at the same time, the conductors are still carrying current and therefore could overheat if not properly derated. To further understand this, let's delve into the specifics of Section 310.15b2 and the concept of ampacity derating. Ampacity refers to the current carrying capacity of a conductor, which is the maximum current, in amps, that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and the ambient temperature. The NEC provides ampacity tables, such as Table 310.15b16, which lists the ampacities of various conductors based on their size and insulation type. However, these ampacity values are based on specific conditions, such as an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit, and no more than 3 current carrying conductors in a raceway or cable. When these conditions are not met, the ampacity of the conductors must be adjusted or derated. Section 310.15b2 specifically addresses the adjustment factors for the number of current carrying conductors in a raceway or cable. When the number of current carrying conductors exceeds 3, the ampacity of each conductor must be reduced according to the adjustment factors provided in Table 310.15b3. These adjustment factors account for the fact that as the number of current carrying conductors increases, the heat generated by each conductor can raise the temperature of the surrounding conductors, potentially leading to overheating. For example, if there are 4 to 6 current carrying conductors in a raceway or cable, the ampacity of each conductor must be reduced to 80% of its original value. If there are 7 to 9 current carrying conductors, the ampacity must be reduced to 70%, and so on. Now let's consider the specific case of 3-way and 4-way switch loops. In a 3-way switch circuit, there are 2 switches that control a single load, such as a light fixture, from 2 different locations. The circuit typically consists of a supply conductor, 2 traveler conductors, a switch leg conductor, and a neutral conductor if required. The traveler conductors run between the 2 3-way switches, allowing the load to be switched on or off from either location. In a 4-way switch circuit, there are 3 or more switches that control a single load from multiple locations. The circuit includes 2 3-way switches at the ends and 1 or more 4-way switches in between. The 4-way switches have 4 terminals and are wired in a way that allows the traveler conductors to be switched, enabling the load to be controlled from any of the switch locations. The proposal suggested that because the load is alternated between travelers in 3-way and 4-way switch circuits, the traveler conductors should not be included in the derating calculations. The argument was that since the load is not simultaneously connected to both travelers, the conductors are not continuously carrying current at the same time. However, the NEC committee rejected this argument, emphasizing that all live conductors carrying current must be included in the derating calculations, regardless of how the load is connected. The rationale behind this decision is that even though the load may not be connected to another supplying conductor at the same time, the traveler conductors are still energized and carrying current during certain periods of operation. This means that they are generating heat, which can contribute to the overall temperature rise within the raceway or cable. If the conductors are not properly derated, they could overheat, potentially leading to insulation damage, conductor failure, or even a fire. It is important to note that the NEC is a consensus-based code that is developed and updated by a committee of experts, including electrical engineers, contractors, inspectors, and manufacturers. The code is intended to provide minimum safety standards for electrical installations and is widely adopted by jurisdictions throughout the United States. The NEC is not a design manual and does not provide detailed instructions on how to design electrical systems. Instead, it sets forth the basic requirements for safe electrical installations. Therefore, it is the responsibility of qualified electrical professionals to apply the NEC requirements to specific situations and to design electrical systems that are safe and compliant. In the case of three-way and four-way switch loops, it is crucial to follow the NEC requirements for conductor derating to ensure that the conductors are adequately sized and protected. This involves calculating the total number of current-carrying conductors in the raceway or cable, determining the appropriate adjustment factors from Table 310.15b3, and applying these factors to the ampacity of the conductors. By properly derating the conductors, it is possible to prevent overheating and ensure the safe and reliable operation of the electrical system. In addition to the number of current-carrying conductors, there are other factors that can affect the ampacity of conductors, such as the ambient temperature. Section 310.15b of the NEC addresses the adjustment factors for ambient temperature. When the ambient temperature exceeds 30 degrees Celsius, which is 86 degrees Fahrenheit, the ampacity of the conductors must be reduced according to the adjustment factors provided in Table 310.15b2. These adjustment factors account for the fact that as the ambient temperature increases, the ability of the conductors to dissipate heat decreases, potentially leading to overheating. For example, if the ambient temperature is 40 degrees Celsius, which is 104 degrees Fahrenheit, the ampacity of conductors with a 75 degrees Celsius, which is 167 degrees Fahrenheit, insulation rating must be reduced to 88% of their original value. If the ambient temperature is 50 degrees Celsius, which is 122 degrees Fahrenheit, the ampacity must be reduced to 76%, and so on. It is important to consider both the number of current-carrying conductors and the ambient temperature when determining the ampacity of conductors. In some cases, both adjustment factors may need to be applied, resulting in a significant reduction in the ampacity of the conductors. To ensure compliance with the NEC requirements, it is essential to consult the applicable tables and adjustment factors in Section 310.15b2 and to perform the necessary calculations. Furthermore, it is important to select conductors with the appropriate insulation rating for the specific application. The insulation rating of a conductor indicates the maximum temperature that a conductor can withstand without degradation. Conductors with higher insulation ratings are generally more resistant to heat and can be used in higher ambient temperatures. The NEC provides tables such as Table 310.104a, which lists the various types of conductor insulation and their corresponding temperature ratings. When selecting conductors, it is important to choose a type that is suitable for the expected operating conditions. In summary, the NEC Section 310.15b2 requires that all live conductors carrying current be included in ampacity derating calculations, regardless of how the load is connected. This includes the traveler conductors in three-way and four-way switch loops. The proposal to exclude these conductors from derating was rejected because it would compromise the safety of the electrical system. By properly derating conductors and selecting appropriate insulation types, it is possible to prevent overheating and ensure the safe and reliable operation of electrical installations. It is crucial for electrical professionals to stay informed about the NEC requirements and to apply them diligently to all electrical work. This helps to protect people and property from the hazards of electricity. The NEC is regularly updated to reflect the latest advancements in electrical technology and safety practices. It is therefore important to consult the most recent edition of the code to ensure compliance.